So, today's class is going to be about leaves, and just the leaves. We're not going to talk about the ginkgo and the Poaceae family specifically. We're just going to talk about leaf characteristics and their modifications. And we're focusing again on the monocots and the dicots. So obviously this is part of my lemongrass. This is a monocot. So you would remember way back when that the mono characteristics are such that they're herbaceous, soft stems, green, and the leaf venation, so the pattern of the veins, is parallel, okay? Whereas this here, which is one of my beautiful ornamental salvias, is a perfect example of the opposite. You've got soft, wide, broad green leaves. You've got a stem that is a little bit woody and herbaceous at the top, and then you've got reticulate venation on your leaves. Now, the other thing we discussed last week in our stem class was, of course, the presence of nodes and internodes. And if you remember, I said the node is the point of proliferation or new growth. And most of the time it is a leaf, as it is in this case, or it can be a new stem axis, or it can be a flower, which is not that common. So this is a beautiful example of a dicot that has relatively evenly spaced internodes. So remember, the space in between your nodes, which are these points here, if we can just zoom in on that, okay, is relatively even. That's your internode. These are your nodes. This in here is your axillary bud, okay? That is in your leaf axil. So we spoke about that last session, and remember that as we get to the top, of course, the space between the nodes becomes closer, okay? So we're going to look at what's happening from beyond our nodal points today. So obviously in this particular specimen, you can see that we've got two leaves in our leaf axil. But we're also going to look at how the leaves are arranged on the stem in relationship to one another, how they're attached, whether they are simple or compound leaves. So a simple leaf is like this one, where it is just made up of one entire leaf surface. We can just see how beautiful that one is. Whereas a compound leaf is made up of a whole lot of tiny leaflets or small leaflets. So like this one, for example. This is actually an ornamental bamboo, and believe it or not, from this point to here is one entire leaf. So all of these little leaflets here are part of one entire leaf surface. How do we know that? For starters, this is actually a monocot, believe it or not. This is a type of bamboo. But there are no buds at these points. So again, the significant thing for differentiating between a simple leaf and a compound leaf, it looks like I've got an umbrella on my head, I'll just put that one down for the minute, is whether there is a bud in the leaf axil. So if we look at this one, for example, this is a nice clear example of a compound leaf with, if you can just focus in on there for me, Peter, there's a little axillary bud in that leaf axil. Can everybody see that? So you've got a little bud in there, okay? So the presence of that and lack of the buds in these points tells us that this is one entire leaf, okay? So it is not a whole bunch of little leaves on a new stem axis. So your leaf is normally made up of what's known as a lamina. And your lamina is your leaf surface. So in this one, this is a beautiful example of one entire leaf surface. Okay, it's nice and smooth, nice edges. You can see that this line going down underneath here, this is like our backbone, so that's your midrib, okay? And all of this is the leaf lamina. This edge around that lamina is your leaf margin. Now, looking at leaf margins and looking at leaf shapes can be quite difficult because they can vary a lot depending on where the plant is growing. So whether there's shade, whether there's too much sun, whether there's enough fertilizer, and so on. So it's going to be pretty much impossible for you to try and work out leaf shapes and margins completely clearly. So they're not as cut and dried as, say, for example, the venation, which is the pattern of the veins. So we're going to have a look at now how the leaves are arranged on the stem axis. And one of the reasons why I get such a big piece is so you can easily recognize patterns. Now, this one, it sort of looks a bit confusing, and you look at it and go, okay, well, how is that actually arranged? And you really have to actually turn it around this way. So you can see that there's a pattern, that there's one leaf in every 4 or 5 that actually comes off the back, okay? So this is actually known as an alternate spiral or an alternate disticus pattern, okay? Whereas this one, actually let's just go with straight opposite for the moment. I've just got to dig it out of the bucket. Okay, just bear with me. Let's have a look. Okay. Buried in here somewhere. Probably had too many. Okay. So this is a beautiful example, and this is one of the jasmines, of a straight opposite arrangement. And you can see that there's a new stem axis coming out of this leaf axil here. And you have one simple leaf at these nodal points, okay, on either side, of course. So that is relatively straightforward, and can I say not that common, okay? It is actually unusual to see this type of pattern. If you're looking at this pattern and this pattern, they are actually the same. So these are part of the Lamiaceae family, and when we discuss the Lamiaceae family, one of the significant factors of similarity in this family is what's known as an opposite decussate leaf arrangement. So that means we have 2 leaves going this way, 2 going this way, 2 going this way, and so on. So each pair is at right angles to one another, okay? So if you look at this one, you can see that quite nicely if we just pick out those buds. So you've got to remember what is actually inside there. And I'll talk about the types of attachments in a minute. Okay, if we just move that down. See how we can see 2 going this way, 2 this way, 2 this way, and so on. So you've got to disconnect yourself from the confusion of what is around that nodal point, not to get too distracted. Something like rosemary is extremely distracting, or lavender can be very distracting. You can be so distracted by these little axillary buds that you don't actually recognize the pattern. but the pattern is definitely also there. So if we just go take those out of there. So we've got 2 leaves this way, 2 that way, 2 that way, bit stubborn, and so on. Okay, so everyone should be able to see that pattern, and it is the same in every single plant in the Lamiaceae family. So I'll just put those down for a moment, move them aside. I'll just put my orchid over here. Let me just dig out my rosemary. Oh yeah, there it is. Okay, so rosemary's even harder still because you have this mass of what looks like leaves all in the one spot. So I'm just going to take that bottom section off. Okay, don't worry, I've got plenty more. Now, so this takes a little bit of practice, so you need to take the buds out of the leaf axil. So I'm just taking them out of there, taking that one out of there. Then we're going to take them out of here and take that one out of there, and so on. Everybody see that pattern? So once you actually make it clear for yourself, it's a lot easier. So you can see 2 going this way, 2 going this way, and so on. And you can also see that your nodes are really close together, so the internode space is not very far apart, and you've got soft herbaceous tips, whereas this bottom section is quite woody. And that was one of the characteristics we mentioned when we discussed those differences between monocots and dicots. So the next type of pattern or arrangement is whorled. Now whorled, and we'll come back to whorled when we're doing flowers next week, means that there is more than 2 structures at one nodal point. So this is one of my gardenias, well, it's the only one I've got actually, and you can see you've got 3 leaves at this point. Okay, everyone can see that nicely. 1, 2, 3. Sometimes you might have 4, sometimes you might have 5. 3 is relatively common. Okay. The other one was basil, and you'll see that in the slides, something like the dandelion, you've got the leaves at the base, and whatever comes up from those basilar leaves are actually the stem axis for the inflorescence or the flowers. So we're going to look at attachment now, and attachment takes a little bit more. So if I just go back to my original lovely salvia, when you're looking at describing the anatomy of the leaf, you have one more part, which I should have mentioned in the beginning, but that's okay, and that is your leaf stem. And this is called the petiole. Now the petiole goes usually obviously from your node to the leaf lamina. So this particular type of attachment is known as a petiolate attachment. Now you do have to try and remember this terminology because we're going to have new terminology that sounds similar when we look at flowers. So this is very clearly a petiolate attachment of a simple leaf. If we go back to our compound leaf, we can see that there is a petiolate attachment, but there's a little bit of a lump. Now you can have what's known as an articulate petiolate attachment, and that's what this is. This one's a relatively smooth transition. It's not as lumpy as others. If you look at this one on the back here, we've got a bit more of a lump there. just in there. And we've definitely got quite of a lump here. So in this one, there's an obvious lump. So that's a bit like your shoulder joint. You know, that is an articulate joint, an articulate attachment. So there's an obvious knobbliness, lumpiness there. And so it is usually associated with a petiole. So it is actually known as a petiolate articulate attachment. And in this case, of a compound leaf of a monocotyledon. Now, if it is neither of those, and if your leaf is attached directly onto the stem where there is no petiole whatsoever, then that is what's known as sessile. So if something is described as being sessile, that means it is attached directly. And we're going to use that word again when we're looking at flowers. So this is a sessile attachment of a linear leaf shape. And we're not going to talk about shapes today. I want you to read those for yourself. Of a dicotyledon that is attached or arranged in an opposite decussate pattern. So if it is none of those, if it is sheathed, for example, then that brings us back to our monocots. So sheathing is the descriptive term given to the petiole, so the leaf stem wrapped around the stem axis of the plant. So that is very different to decurrent. Decurrent is where the leaf base, so the leaf lamina, goes all the way to the base. There is actually no petiole. Okay, so I've got, look at my aloe. So my aloe, which this one I've just broken off, I'm sorry. So we have an interesting combination of a leaf lamina that goes all the way to the base. So I've just pulled this out of the ground. And we have obviously a monocot leaf, so very obvious. It's a simple leaf. And we're going to talk about vestitures as well. And I'm going to talk about some more modifications in a moment. So let's just recap and make sure we've got that information. So we've got either a simple leaf or a compound leaf, and we have one entire leaf margin, which is that whole edge there. We have a leaf lamina, which is the surface, and the backbone is the midrib. And the most important part is the petiole, or it might be missing. Okay? So let's have a look at a different type of attachment. One more, there's one more, which is, sorry, I've got so many buckets. Okay. So this one, this is a dock. And you can see that initially, this is basal, okay? All the leaves are sitting at the base, and then this aspect here is actually our stem or flowering axis. But we've also got leaves that look a little bit as though they're perfoliate, although this is quite a young specimen, so it's not as clear on this. And we've also got some modifications on here. So let's just have a bit of a look at the types of modifications we have. So one of them, which we covered last week, was tendrils. Now remember I said the significant factor with the tendrils is where does it come from? Does it come from the stem axis? Then it is a stem modification. If it, though, comes from the leaf axis, then it is actually a leaf modification. So I do have one in one of these buckets. Probably got too many buckets. Where'd it go? Sorry, I'll just have to rearrange these a little bit. Here we are. Okay. So this is a South American passion fruit that I grow. Now, in this case, you need to work out, though, is it actually a leaf modification or a stem modification? So first of all, you can see that we have one leaf missing, but we have an alternate leaf arrangement of one entire simple leaf that is a dicot. Now there's our tendril there, and if you can see, it's coming out of our leaf axis. So it is actually a stem modification because it's not coming off the petiole. If this was a leaf modification, it would be coming off the petiole just around about in this area here. So this is actually what I was talking about from last week. This is most definitely a stem modification. So the next type of modification is, of course, back on our aloe, is for storage. So similar to our stem modifications, so our onions and our tubers and so on, this is modified for water storage, if you like. So obviously we harvest the gel from this. So we have two modifications in one. We have the leaf modified for storage of the water, but we also have these spines on the margin, okay? So that is also relatively common, that you might have two modifications in one. And I did mention this last week. So we have a monocotyledon with decurrent leaf arrangement of a simple leaf that has a spiny margin and is modified for storage. Okay, now the next ones are bracts. So I did put the bougainvilleas are in the slides, but we're going to talk about bracts, particularly more so when we cover the Asteraceae family. So a bract is a type of leaf modification. If you look just in there, that's actually where the flowers are. So those funny three little things there, they've already developed into the fruit. But the bracts are a leaf modification. They are not a flower as such. Now the next one are the ligules. Now, pardon me. All right, so your Poaceae family has these little flaps. These are your ligules. Okay, these are a leaf modification that is relatively typical or characteristic of the grass family. So we have a long, simple leaf that has parallel venation. It's a monocot, and it has this sheathing as well as a ligule. Now, the spines and the prickles you know about. The other thing that I wanted to talk a little bit about was the vestiture. Now the vestiture is what type of leaf surface we actually have. And your normal one, nice and green. Okay? So that's nice, plain, green, vestiture, glabrous, and so on. Okay, this is nice and simple and green. Once we start having a little bit of fur on there, like this is some of the Lamiaceae, they have what's known as a pubescent vestiture. So this one is beautiful and soft. This one, which is a geranium or a pelargonium, is quite sticky, okay? And then this one tends to be a little bit softish, and so you can see that that has to be one entire leaf, even though we have this sharply indentated margin here. But there's our leaf axil and our bud right in there, okay? So this is actually an Asteraceae, and they're worth having a bit of a look at. You can see, again, we have this alternate disticus pattern. We've got one leaf coming up off the back, but the others look as though they're just alternating straight. Now, this one more, my favourite one when it comes to vestitures. This is one of my peppermint geraniums. So you have this beautiful, lovely, soft vestiture. So you've got a leaf lamina and the vestiture is on top of that, okay, if that makes sense. So most of your dicots will have something. This is my bay tree and it's pretty straightforward, pretty simple. And you can see how there's a very articulate attachment there. So I want you to spend some time looking at different plant specimens and going through, looking at initially, is it a monocot, is it a dicot? What type of leaf margin do we have? What type of pattern, so arrangement? The arrangement is, of course, the relationship of the leaves to one another on the stem. And that's very different to the attachment. The attachment is how that leaf is attached on the stem. Work out, is it a compound leaf? Is it a simple leaf even? And your leaf axil or your axillary bud will help you do that. One that will throw you a bit of a curly one is this, and I thought I'd pick one of my nasturtium leaves. This is not a petiolate attachment. This is most unusual because you can see that the leaf lamina is attached underneath, like you've got that petiole underneath that surface. You don't have it at the base of the leaf. So this is known as a peltate attachment. So you're not meant to remember that, but you will come across it, and especially if you're growing nasturtiums, you'll see that. You might also come across what we discussed last week, which was a stem modification. And that's this sort of thing. You've got stolons, so those runners, which we talked about. So you'll see different types of combinations of pretty much anything we've covered the last couple of weeks. And you can see even on here, you have a whorled leaf. This is actually, no, you don't, I beg your pardon. This is actually a peltate leaf because you have 1, 2, 3, 4, 5. So this is palmatophid. So like fingers, not peltate, okay? So you'll see variations, and you really need to take your time to be able to go through and work out where it fits. It doesn't always fit where you want it to. So, and even you'll get tangled, even just from writing notes for yourself. You got to go, okay, start from the beginning. Is it a monocot? Is it a dicot? And sort of gradually work your way along from there. And try and stick with our flowering plants, because next week we're going to look at the simple solitary flowers. And then, of course, after that we move on to the inflorescences. Okay, hope you enjoyed that, everybody. Get stuck into it, and I'll definitely see you in the lesson tonight. Okay, thank you.